Hi everybody, this is a video tutorial about graphing absolute value functions. So we're going to learn about these functions, or what they are and why they look like that and how to draw them. Just so you know, I did this today in my class and it didn't go real well. That's why I'm making the video. So hopefully this will be a really clear explanation. Let me know in the comments if it's not. Just going back to basics, absolute value, what does it mean? It means how far the number is from zero, or what's the size of the number. It doesn't matter about its direction or its sign, just how big is it. For example, the absolute value of -4 equals 4. The absolute value of 3 is 3. It's 3 away from 0. The distance in here is 3. Okay, and the absolute value of 0 is 0, of course, because 0 is 0 away from 0. I hope that didn't confuse you. So yeah, we're just looking at how far away it is from 0. Might be easier to remember this, that when absolute value of x equals x when x is positive, and equals negative x when x is negative. Okay, so if x is bigger than 0, it's just x. If x is less than 0, if it's negative, then you negative it. So it'll be a positive number. Absolute value is always a positive number, or 0. Before we go any further, you might hear people say modulus, which is not 100% accurate. It's okay, but it does have a special other meaning. So let's call this absolute value and leave modulus for complex numbers. Definitely don't say mod or modulo. Physics people sometimes say magnitude because they use the same symbols. It's okay, but let's just say absolute value, because with numbers and functions, that's what we're talking about, the value. Two ways you could work out how to graph it. We could plot the points, and you see here I've got x values, and then I've got my absolute value of x's, and there they are. All the negatives have become positive, 0 and the positives just stay the same. So this is x and y, so this is coordinates. So there's our coordinates, -8, 8, -6, 6, -4, 4, etc. So, because this is a continuous function, I've got to join it all up. So that is what y equals absolute value of x looks like. An alternative way to think of it is, this is y equals x, this dotted line. Another line going in the opposite direction is y equals -x. So when x is positive, it looks just like that line. When x is negative, it looks like y equals -x. Or you can think of, there's y equals x, and you've got to flip this bit up, because when x is negative, you can't have y being negative, so you've got to flip it up. Okay, so that's two ways you could work out what y equals absolute value of x is, but you kind of just got to remember what it looks like now, and that we'll be able to do a lot of other things with it. By the way, if you got y equals negative absolute value of x, it's just going to be the same thing flipped over. All the positive y values have now become negative, as you can see in the table here. So it's just flipped over or reflected in the x-axis. In another video, we'll talk about how if you put a negative in front, it is a reflection in the x-axis. If you put a negative inside the brackets here, or inside the absolute value signs, it's a reflection in the y-axis. It doesn't look any different from y equals absolute value of x, but you can see how we got there is a little bit different. So y equals absolute value of -x and y equals absolute value of x will look exactly the same. Okay. Now we're going to switch it up. We've got y equals absolute value of x plus 4. What does the plus 4 do? Well, let's make a table. Okay, add 4 to everything, and then take the absolute value. Order of operations. You always got to do what's inside the brackets first. So we add 4, and then we absolute it. Okay, and so we plot those points and join them up. Okay, but now we've done that, we can probably have a think about it. How does that look with respect to what we had before? Well, there's y equals absolute value of x. That's y equals absolute value of x plus 4. So the plus 4 has moved it 4 to the left. All right, where x used to be 0, now we've got negative 4. Because look, negative 4 plus 4 equals 0. So I've moved every single point back 4. Just to prove that, here's a few more. There's y equals absolute value of x minus 6, so let's move 6 to the right. Absolute value of x plus 5 is 5 to the left. X plus 8, 8 to the left. Okay, so you can think about it as, if you put plus 5, it's happening 5 units earlier. If you put minus 6, it's happening 6 units later. Or probably easier in this case to think of, when does y equal 0? Well, with the red one, y equals 0 when x equals 0. With the blue one, y equals 0 when x equals minus 5. So minus 5 plus 5 equals 0. So you can work out where the 0 is and draw it in. Okay, hope that wasn't too fast. Rewind if it's becoming unclear. But we're moving on now to absolute value of x plus 4. The plus 4 is out the front of the brackets. So, okay, so we take our values of x, we take their absolute values, then we add 4 to them, and now we can plot those points, and there's our new function. And hopefully, again, we'll do this in an easier way. We'll look at y equals absolute value of x, and then y equals absolute value of x plus 4. You see what's changed? The y values have changed because we've added 4. The yellow has added 4 to all the red y values. So you take this y value, add 4. Take this one, add 4. Take this one, add 4. So when you put a plus 4 on the end, you're moving everything 4 up. Just to show you that again, there's absolute value of x. There's y equals absolute value of x minus 6. Y equals absolute value of x plus 5. We're moving it down 6, we're moving it up 5. Okay, there's numbers on the end, move it up and down. Also called vertical translation. Okay, maybe it's easiest to think about this. What's the lowest value of y? Lowest value of y in the red one, okay, lowest value of absolute value of x is 0. So lowest value of blue one is 0 plus 5, 5. Lowest value of the yellow one is 0 minus 6, negative 6. Okay, so that might be a helpful way to think about it as well. What if we had absolute value of 2x? Or you can also see it that way. Okay, so it's going to look like that. Okay, you can do it by doing the table, or you can think of it as a horizontal stretch, in this case horizontal compression. If you put the 2 outside, you think of it as a vertical stretch, so it's vertical there. Or you can think of it, the absolute value of y equals 2x. So the gradient here is still 2, isn't it? The gradient on this left side is negative 2. So the gradient of that is the absolute value of 2. Okay? So that's how you can work out graphing the absolute y equals the absolute value of 2x. Same thing with y equals absolute value of negative 2x. So abs negative 2x is the same as abs 2x, and but here if you put the negative 2 outside, it flips it over. It's reflected in the x-axis. So whether you have the 2 inside or outside, the absolute value signs doesn't make a difference, but if you have the negative inside, it makes a huge difference. Okay, just really quickly, here's 3 examples of different lines, and you'll see they all have something in common. This one is 2x plus 4, alright? So it looks like this right-hand side looks like y equals 2x plus 4. This left-hand side, but it can't go lower than 0, so the left-hand side goes up here. Or you can also think of it, it's been stretched by 2 and it's been moved 2 to the left. So it's moved 2 to the left and then it's stretched, so its gradient's now 2. if you got this one, you got to think about the lowest point. See, the lowest number here inside the absolute value sign is 0. So 0. So 0 plus 4 is 4. So the lowest point there is 4. And on this side, it's got to be reflected up. And here, -2. So the -2 flips it the other way around. Plus 4. Well, plus 4 is going to be our y-intercept again, because this can equal 0. So it's y-intercept, but it's going to be the opposite way around, right? Because of your negative. Or you can think of it as y equals -2x plus 4 is sort of a line going that way. But again, on the left-hand side, on the negative x-axis, you've got to flip the numbers over. Okay, hope that was helpful. Here's just a little summary. This may not make sense to everybody, depending on whether you've done functions or not. But here, each of these numbers, a, b, c, d, represents a transformation. Okay, and you can see these are done just quickly. The 3 here means you've got a gradient of 3 on that side and -3 on that side. The -4 means it's moved 4 to the right. The -6 means it's moved 6 down. So this here is 4, -6. The -2 here means you got a gradient of 2 there and a gradient of -2 on this side. The +2 means it's moved 2 to the left. The +4 means it's moved 4 up. So that vertex there is -2, 4. Alright, I hope this video made sense to you, and good luck solving and graphing absolute value functions.